linear first order ODEs are those that can be written in the form dy dx plus p of x times y is equal to q of x. So here we want to write it with the derivative by itself plus some function of x times y equals and then another function of x. If you have an equation that's linear in form, then your first step in solving it is to find what's called an integrating factor. The integrating factor will be in the form, this is I of x, I for integrating factor, is an exponential function e raised to the integral of p of x dx. Okay, so on number 8, write the equation in the form shown above. This is in linear form. And then introduce the integrating factor and then go through steps to solve it. So here our first step is going to be to get the derivative term by itself. I'm going to take this entire equation and multiply by 1 over t natural log of t. That way my t natural log of t will cancel from my first term, and it'll leave me with the derivative term, dr dt, plus, I'm going to have 1 over t natural log of t multiplied by r. I get 1 over t natural log of t multiplied by r equals, on the right side of the equation this t will cancel and I'll be left with e to the t over natural log of t. Okay, so notice that what I have now is in linear form. I have my derivative term, I have my function of t times r, and then I have a function only of t. Okay, the integrating factor for this equation, notice that instead of x's we have t's as our variable. So my integrating factor is going to be a function of t is going to be e raised to the integral 1 over t log t, and we're integrating with respect to t. So let's see, when I integrate 1 over t log t, if I let u equal to log of t, yeah, we could do that. If u is equal to natural log of t, then du would be 1 over t dt. Notice that I have the 1 over t dt. That'll put my log of t is in my denominator. It's going to give me 1 over u. So it's going to give me this. It's going to give me the 1 e raised to the power of the integral of 1 over u du. And when you integrate 1 over u with respect to u, you're going to get the natural log of u, which in this case is natural log of t. So I get e raised to natural log of t. Now that's messy, right? But and one other thing I should mention is that when you do this integration, you don't include the constant of integration. You don't need the plus c here. So This looks messy, but the nice thing is that e and natural log are inverses of each other, and they cancel, those operations cancel each other out. So that e and the natural log cancels, and it leaves you with just the natural log of t. So natural log of t is going to be our integrating factor. And we want to take that previous equation and multiply everything. So everything here gets multiplied by the integrating factor. Everything gets multiplied by natural log of t. So my first term becomes natural log of t times dr dt plus, on my second term, natural log of t will cancel with this natural log of t in the denominator, and it's going to give me 1 over t times r, and on the right side the natural log of t's cancel to leave you with just that e to the t power. That's real nice. Now this equation that we're left with still may not look real nice, but when you have a linear first order ODE, after you introduce the integrating factor, it's going to leave you with the left side of the equation so that it can be written as a single derivative with respect to t. And if you take this first term that you have, and then your variable, your dependent variable, in this case r, this left side of the equation should be the derivative of that, the derivative of natural log of t times r. You can test it by looking at the product rule for derivatives. This is our u, that's a v. When you do the derivative of u times v, you're going to get u prime v plus v prime u. U prime is the derivative of natural log of t, that's 1 over t, times r, that's our second term, plus v prime times u. V prime is going to be the derivative of r with respect to t, dr dt, times natural log of t. With a linear first order ODE, once you introduce that integrating factor, you will always be able to write the left side of the equation as a single derivative. Okay, once you write that second side as a single derivative, then the goal is to undo that derivative. And we can undo that derivative by integrating with respect to the same variable. Integrate with respect to t. Do that operation to both sides of the equation. I'm going to bring this up just a little bit in case I need room. And on the left side of the equation, this integral and that derivative will cancel each other out. They're inverse operations. It's going to leave you what you have inside of brackets here. Natural log of t. I'm going to put the r in front, so I don't think it's the natural log of tr, but this is natural log of t times r. R natural log of t. And now here on the right side, when we integrate, we do want the constant of integration. When you integrate e to the t power, you're going to get back to e to the t power. Add my constant of integration. And if I can, I want to solve for r, and we can solve for r by dividing by natural log of t. And I'll just write it this way. So I have e to the t plus c, all of that divided by natural log of t. And there's my answer.